in exercise 10b, we're going to focus on the actual stationary points. So we're not so much interested in whether the graph is increasing or decreasing anymore, or just for now. We are just going to focus on when the gradient is 0. And we've seen before that when the gradient is 0, let me just go back. When the gradient was 0, we had situations like here, and I've already explained that that would be called a local maximum point. Got this one, and that would be a local minimum. This is an interesting one. It's not a max, it's not a min, but the gradient, if we could draw the gradient right there at that point, the gradient would be 0. And you'll see in exercise 10b, we actually identify this point, as well as the max and the minimum. Another local min, a local max, a local min, and an absolute minimum. Okay, let me go back and actually let's establish that there will be 4 types of stationary points. So we've got this one, which we call a maximum turning point. The gradient's equal to 0. A minimum turning point. And then we've got these points, a point of inflection. Point of inflection. It's something significant is taking place here, and what we say, it's being inflected. And we've got 2 situations. So we've got this one where, and I'll introduce the concept now, the graph is going from concave down through this point of inflection to what we call concave up. And over here we were concave up, and then it's going concave down. Now, in that situation, you find that you may have a point of inflection if you've got this change in concavity from concave down to concave up. There's been a change in concavity. So the focus of this exercise is to identify, identify if and where we have a stationary point. So that's number 1. What x values give us a stationary point for a particular function? And we know that we will solve for x, for where the first derivative is equal to 0. Once we've got those x values, we're going to establish whether we've got a maximum, a minimum, or a point of inflection. A maximum, a minimum, or a point of inflection. And we're going to do all of this without drawing the graph. So it's all going to be algebraic. So if we were to look at our, for example, our maximum, we definitely know that at this, whatever this x value is, the gradient was 0. We can see that leading up to that, if we took x values just to the left-hand side, we can see that the gradients here were positive. Right at this point, the gradient is 0. And then if we consider the x values to the right-hand side, then we can see that the gradients are negative. So in a situation where your gradients change from being positive, go to 0, and then negative, you can establish that you've got a maximum turning point. Now the way we actually set it up is to put our information into a little table like this. So we just have, well, I guess we've got 4 columns, 2 rows. Along the top row, we're going to put our X values. We will have identified where the stationary point occurs. So these get replaced with actually a number. So if we've established that there was a stationary point at X is equal to, say, 3, for example, I would have a 3 sitting in my table there. My second row is telling me about the derivative, and I've found that X is equal to 3 by putting the derivative equal to 0, so I know that the derivative is actually 0 when X is 3. Then I choose an X value. Remember we said we would choose an X value to the left-hand side, so we just choose a number to the left of 3. To the left of 3, I think a fair enough number to choose is a 2. And on the right-hand side, we might have 4. So we're going to test the sign of our derivative when X is 2, for example. If we find it's a positive number, doesn't matter how big or how small, as long as it's positive, we put that in there. We know that at this X is 3, our derivative is 0. And if we find then at 4, the value of the derivative, when we subbed X equal to 4 into the derivative, if we've found that that's gone to a negative number, then we know we've got this shape. Gradients were positive, gradients were 0, gradient was 0, then gradients are negative. And that shape we would call a maximum. In a similar way, we could identify a minimum. So again, we establish the actual number or X value for the stationary point. And the way we do that is we solve for f dash x equaling 0. And then we take, again, and let's just make them the same numbers. So let's just say this was happening at X is 3. I'm choosing a number to the left. I'm choosing a number to the right. I know that if I sub 3 into the derivative, it gives me a 0 because that's what I solved. If, on the other hand, I had that when I subbed X is 2 into the derivative, I got a negative number, well, I'd just record that it was negative. If then on the other side I got a positive, then I know the graph was coming down, the graph was stationary, the graph went up, and that would actually be called a minimum. The horizontal point of inflection, this point of inflection, is when, again, we've solved for some value of X where the derivative is equal to 0, so let's again say it's 3. Then I choose a number to the left, which is 2, a number to the right, which is 4. And when I look at my actual gradients, say leading up, and we know at 3 will be 0, leading up, so at X is equal to 2, we can see it's a positive gradient, positive, some positive number, yeah. And then when we go to some, on the right hand side, to some bigger values of X, I can also see that the gradient is a positive. So if the gradient was positive, then it went 0, then it went positive, we've got this special situation called a point of inflection. we get a similar situation, and in fact it's still called a point of inflection, if you find that at a particular point your gradient is equal to 0, but leading up to that point you had negative numbers, negative values for the gradient. Then after that point you've got still negative values for the gradient. If you've got that situation also, so negative, naught, negative, you also have a horizontal point of inflection. So throughout this exercise, you'll be asked to identify the type of stationary point. And you will show your little table. It will be your working out, where you've got your x values and your derivative values for different points of x.